All right, so talking about vaccines then, I'm going to move this off to the side. Today's agenda then, what I want to talk about is a little bit about where we've been. Oftentimes you hear the comment that we can learn from our history, right? So where have we been? What have we done in the past successfully? What mistakes have we made? How can we get better for the future? So it's always good to look in the past to make decisions for the future, right? That's why we learn history to begin with, so we don't repeat mistakes, right? We learn from our mistakes. So we're going to talk a little bit about how vaccines work, some misinformation surrounding vaccines, and then we're going to zero in specifically on the COVID-19 vaccine. So according to the World Health Organization, immunization is one of modern medicine's greatest success stories. So it is the single most successful public health initiative ever developed. So immunization, once we were able to develop and implement vaccines, the human suffering globally and here in the United States was significantly decreased. So prior to the 1940s, we really didn't have very effective any vaccines that we could rely on. And polio and measles were illnesses that caused massive deaths, hospitalization, and lifelong effects for children in the U.S. and internationally. So here is a polio vaccination effort in the schools. This was a popular way to deliver vaccines quickly and effectively, and it was government funded, so there was no cost to anybody. So this is here in the U.S. in our schools, students lining up for polio. And then this one is the oral polio vaccine that we use internationally. Very low cost, very effective, massive immunization effort that gave very good results. When we look at major illnesses that affected the human population, smallpox is in the upper right-hand corner. You can see two children. This boy is infected with smallpox, very deadly disease. Polio, these two individuals is a child in an iron lung. The polio virus causes, it invades the nervous system in a small percentage of people that get polio, and it causes paralysis. And it causes paralysis of the diaphragm. So those people are unable to breathe on their own, and they have to go in this special metal tank called an iron lung, and it changes the pressures necessary for breathing. So there is still a man here in the U.S. that lives in an iron lung, and it's just incredible. And then this child has measles. So you can see how ill this child is just by looking at his face. So we're going to talk about the MMR vaccine. This stands for measles, mumps, and rubella. So we're going to start out with smallpox. Smallpox estimated to have killed 300 million people in the 20th century. So we're talking about the 1900s. Improved vaccination methods definitely worked to decrease that, and we were able to stop vaccinating in 1972 because there was no human host found anywhere for the smallpox virus. Now that virus only exists in a lab. So we didn't have to vaccinate anymore because it's gone. It was a huge public health success in eliminating smallpox, and it was eradicated worldwide in 1979. And how did we get there? Vaccination alone, vaccination alone. And it's interesting when we look at the history of this disease, when the Europeans arrived here in the Western Hemisphere in the 16 and 1700s, it significantly impacted the Native American population. 70% of the Native American population was wiped out by smallpox. In one year, in 1633 in New England, there was a specific tribe of Native American made up of 16,000 individuals. After smallpox wiped through their population, there were 3,000 left. So it's called the virgin soil epidemic, as Native Americans had no immunity to this disease, and so smallpox and measles, and it significantly impacted their population. So when you look at polio, 1 in 200 infections led to this irreversible paralysis, and then 5 to 10% would die when they were no longer able to breathe, and there were not enough iron lungs to serve everybody that needed them. So it first showed up in the U.S. in 1894. In the 1960s, we had this great widespread vaccination effort. It was eradicated only in 1994, so not that long ago did we finally eradicate it in the U.S. But in 2000, 5 or 6 years after that, we're able to significantly reduce it worldwide. But it still exists in developing countries because they don't have access to the vaccine, and there are still very, very few cases out there. But this is particularly a disease of children. So children, the 5 to 9-year-olds, seem to be the biggest group that contracts this disease in the school system, is when they enter school, when they're around lots of people, is when this seems to show itself. And in the early 1900s and the summers of the 1940s and 1950s, huge epidemics of polio. So again, we give this vaccine now to children, and we don't see any polio here in the U.S. Measles is another one. Prior to 1963, 3 to 4 million infected, 48,000 went to the hospital, 4 to 500 people died. And I had a pediatrician once that said, if we have any vaccine that can prevent even one death from these diseases, if it was your child, would you look at that statistic a little differently, right? And that's the key thing. If we look at when the vaccine was licensed and looking at the number of cases, look at that significant drop. This is just because of the vaccine. So it went from 400,000 to almost nothing, to less than 100,000, down to nothing. Again, if you look between the 1980s and 1990s, it was almost down to zero. But measles still exists internationally. We have not been able to wipe it out internationally. So when people travel to countries that are, beautiful vacation spots, unfortunately, some of those are in developing countries, and people pick up the measles virus and then they bring it home, especially if they haven't been vaccinated, right? If you've been vaccinated, then you go traveling, you're fine, right? In most cases. So a lot of these epidemics have been people that have traveled, they come back to the U.S., they weren't vaccinated, they had the illness, and they spread it to other people that have not been vaccinated. And we have learned that we've needed to do boosters occasionally, but when we look at local epidemics, they're among the most common people that are part of the epidemic are those that have been unvaccinated. So it's always going to be out there because, again, we don't have a global vaccination effort for measles that's been as effective and as serious as polio and smallpox were. But what we don't understand is there's no vaccine on record that has caused more side effects and death than the disease itself. So if we looked at side effects, hospitalizations, and death to smallpox, measles, polio, none of that compares. I mean, those numbers are huge compared to any side effects from a vaccine. And we'll talk more about that. So who do we need to focus on being vaccinated? I put asterisks by the people that are at most risk for death as a result of diseases preventable by vaccines. So infants have a poorly developed immune system. It takes time and exposures to develop our immune systems. So young children, babies, when they develop, say, influenza, or if they should get whooping cough, for example, at 3 months old, the ability of those tiny bodies to fight off those viruses and survive are much lower. The same thing with older adults. We know a lot of older adults that acquired the COVID-19. They had a hard time overcoming the side effects of that illness, and then they died from it. So we really have to be careful. And some people will say, well, you should just breastfeed your baby. Well, unfortunately, there are no antibodies in breast milk from the mother for diphtheria, whooping cough, polio, tetanus, hepatitis B, and Haemophilus influenza B. So there are illnesses that these infants need to be vaccinated for to develop their own antibodies that they cannot get through breast milk. So anybody who cares for infants and older adults, they're also, I have an asterisk by them, because if they're at the bedside and they're carrying this virus to the bedside because they have not been vaccinated, they're putting their patients at risk. And right now at Gunderson, if you choose not to get your flu vaccine or your COVID-19 vaccine, everybody right now is wearing a mask. But in the past, before COVID-19, if you didn't want to get your flu vaccine, you had to wear a mask at work. And we don't know how well a surgical mask protects your patients from influenza if you had it at work. And how would you feel if you were a young person fighting cancer and receiving chemotherapy treatment, and you're hospitalized for that chemotherapy treatment because you had a really low immune system, and a nurse comes into your room and is wearing a mask because they don't want to be vaccinated, and they have young children at home and influenza might be in their house, or they have a cough or a runny nose and you don't know the source of that cough or runny nose. I think that's a very big concern. If I were a patient and I had a nurse that wasn't vaccinated, I would be very concerned if I was immunocompromised and being exposed to that nurse. So there are some people that can't get vaccinated. For example, like the person I just mentioned, those that are receiving chemotherapy treatment for leukemia specifically. Leukemia is cancer of the white blood cells. So we have to sometimes destroy their immune system to kill those cancerous white blood cells, and then they get a bone marrow transplant to give them new white blood cells that are functional. And in that process, we certainly cannot vaccinate them because their immune system is pretty much shut down during that time when they're fighting that cancer. So they can't get vaccinated. Also, if you're actively ill, and your immune system is already responding to an illness, like let's say you're fighting a more serious virus like pneumonia, you're already ill, your immune system is already working hard. We don't want to add more to that by vaccinating people that are actively ill. That's why they always tell you when you go in for a flu shot, for example, or the COVID-19 vaccine, if you have a fever, they don't want you to get vaccinated. They want you to recover from your illness and then get vaccinated. And anybody with a history of a vaccine allergy, we're going to talk about some of those allergies. So it's important that we remember that even though we're healthy, there are people that we're exposed to in our environments that aren't able to get the vaccine. So if we vaccinate ourselves, we're protecting those that can't. So how do these traditional vaccines work? Well, the flu vaccine, polio vaccine, measles, not the COVID-19, but traditional vaccines, we take the virus and we change it to make it non-infectious. So we inactivate or we weaken the virus in such a way that it doesn't cause infection, but enough of the material of that actual virus is there that the body's going to make antibodies to it. So we inject that into a muscle. Muscle has good blood supply. It's going to cause a nice immune reaction. And then your body makes antibodies. So these are the antibodies that are made by B cells in our immune system. And it's going to then attack any new invader that would come in. So if you look at the little smiley face on this virus, it's been weakened. And that's why it has kind of a neutral face. So when we inject that in, this neutral weakened virus stimulates antibody production. Then it takes, 2 weeks, and maybe you need a booster depending on the disease we're trying to protect again. But let's say it's the flu shot. About 2 to 4 weeks later, you have good antibody production. Then you're exposed to the flu virus at work. The minute that flu virus enters your body, so here's the dangerous flu virus. You can see it has the mad face. So this is the bad flu virus that somebody picked up in the environment. Now those antibodies are there, and they instantly shut that virus down, and there is no ability for that virus to cause illness within that person. So they have been vaccinated. They're safe. They're not going to infect other people when this virus enters because it's immediately responded to by the immune system. So this is where there's a little confusion out there because some people are saying, well, I've had my vaccination, but I might still spread COVID-19. We don't have any indication of that. We've never said that to anybody. If you're vaccinated, you're protected and you're not going to spread it unless you're carrying it on your hands. Well, we know in healthcare we should be washing our hands before we touch our patients, right? So as long as you're not carrying it on the surface of your body, you're not going to be spreading it in your breath to anybody if you've been vaccinated. So then you're protected. Now you are part of what we call herd immunity. We want you to be protected by a vaccine, not by getting the illness, because by getting the illness, you're spreading that and getting other people that can't recover from that illness at higher risk of death. So that's how traditional vaccines work. So how does this mRNA vaccine work? Well, we studied a little bit about DNA and RNA in our classes, and messenger RNA is basically a recipe. So DNA is a recipe as well. So DNA, we have the DNA sequence of the COVID-19 virus. We've done great research and accomplished that. So what we've done is we've taken the recipe, the DNA recipe for making a spike protein on the coronavirus. We have that recipe. We use that DNA template to make lots of messenger RNA, because if you remember from protein synthesis, and even if you don't, messenger RNA is a single-stranded recipe of what's on DNA. So messenger RNA goes in, copies DNA, and carries that out into the cytoplasm. Well, we skip that process. When we make an mRNA vaccine, we do this in the lab. We have the DNA sequence of the coronavirus, the spike protein, and then we, using our bioreactor, which is a very specialized device, I certainly have no knowledge of that. That's biotechnology way beyond my interest or understanding. But anyway, we use a DNA template for the spike protein. We make a bunch of mRNA copies, and the mRNA is what we isolate, and we wrap it with a nice little lipid molecule, this mRNA copy of the spike protein only. So the spike protein is just a protein. It doesn't cause illness. It doesn't give you COVID-19. It doesn't make you test positive for the virus, because it's not like I said in the previous where we're giving you a weakened version of the virus. It's not that. It's just a recipe for a little spike protein on the surface of the virus. So we put this in a little fat particle, and then we put it in a vial, and then we give you that in your arm. So we inject that recipe. So again, this is messenger RNA. We inject that into your arm, and this messenger RNA goes into your cells and hooks up with the ribosome in your cell, and your ribosome makes lots and lots of protein from this messenger RNA copy. Now, did I say that the messenger RNA went into your nucleus and messed with your DNA? No, it does not enter the nucleus. Messenger RNA hooks up with an organelle called the ribosome, and it makes protein. And the protein it's making is this spike protein that is found on the coronavirus. Now, it's just a spike protein. It's just a little outside piece of the coronavirus. There's nothing in there, because a virus is a little piece of DNA. There's no DNA in here. This is not the coronavirus. This is a protein on the surface of the virus. It's not DNA that can cause illness and infect your body. So we make antibodies to the spike protein, because this little protein shows up in the body, and the body's like, where did that spike protein come from? Let's make antibodies to it. This is a foreign invader. And the beauty of it is because this messenger RNA, when it entered our cells and we made all this nice spike protein, is we get a huge antibody production. Huge antibody production. So what's the result of that? Young people with good immune systems, they tend to get really yucky feeling after they've had this vaccine, because they had such a huge antibody response. It's the inflammatory immune response that we're triggering and that we want, that young people tend to get a little sicker than older people do because of that huge antibody response. Now we're protected. Now we have all these antibodies, and the beauty of this is because we're using the messenger RNA strand and getting our own cells to make these antibodies and the protein to make the antibodies, we're seeing a 90 to 95% effectiveness. And that is a huge success, because some of our other vaccines, the best we can hope for is about a 50% response is what we hope for as a bare minimum. This is a 90 to 95% effectiveness in preventing the virus. So this is huge. And the speed of making messenger RNA versus trying to grow them in chicken eggs like we do with the influenza virus, we can produce this in about 2 to 6 weeks. And that's the awesome piece of this. So if we look at, again, this is how we make it. So we inject, here's the messenger RNA, here's a little fat particle, we put it inside, we inject it into your muscle, it enters into your cells. So here's your cell membrane, here's the messenger RNA. It hooks up with the ribosome copies it and makes this nice spike protein, and then it's presented on the surface of your cells, and your cells make antibodies to it. So there's no DNA involved in this process at all. There's no DNA in the vaccine, and it's not messing with your DNA inside your cells. So what is the issue? Well, in January 2019, the World Health Organization declared anti-vaccination efforts to be one of the top 10 threats to global health. We have people using non-scientific information. They're using hearsay. They're using personal stories that they read about on Facebook. They're listening to the uneducated, the people without a science background, but have PhDs. I've read articles and looked at, Facebook posts and social media posts of people saying, I have a PhD. And then when you look and see what their PhD is in, one was in English literature. And I thought, my goodness, having a PhD in English literature does not make you an expert on vaccination and how vaccines work in the body. So we really have to be careful. And sometimes you will hear from isolated doctors. I've seen people with MD degrees that are anti-vaccination, people and promoters. And to that, I say, if you know who Ted Bundy is, Ted Bundy was a serial killer. He was also a lawyer. I would not go to Ted Bundy for legal advice. I think he probably has some mental problems. And the same thing when you listen to people that are doctors. Look at what the majority of doctors say, right? If the majority of doctors who have access to patients who are vaccinated and unvaccinated, and they have access to medical literature that they can understand because it's spoken in the language of doctors, let them be your sources of information. Don't listen to the latest news media description from someone who has no idea what they're talking about. For example, I was driving with my husband this weekend. I think it was Saturday morning. There's on Wisdom News, there's an individual that talks, it's early in the morning, he talks about local health things. He does not have a background in science, and he says so many incorrect statements regarding human health that I had to turn it off. I had to tell my husband, you have to turn this off. This is making me scream, because he was absolutely incorrect in so many different things that he said in his radio show. And he does it every Saturday morning. Now, if you're the average person, average farmer, just driving the tractor, listening to this guy talk, he's a nice guy. You would believe what he says because you would assume he's done his research, right? Well, he hasn't. But these people have access through social media, live news, the radio, and people trust that. But we, as a society, this free speech and this access that we have allows people that are uneducated to come out and educate people that don't have the background to determine if that's right or wrong. So let's talk about some of the myths. This is where we need to educate, right? And this is where doctors aren't even doing a very good job educating. And for those of you that are going into the healthcare field, it's kind of our responsibility to help support that, because just yesterday I worked and I had a patient say, my doctor said I need to limit my salt. I'm discharging in an hour and I don't know what that means. I was like, oh my goodness, let's talk about what a low salt diet looks like. So you guys can educate, and you're going to hear these things. Maybe you're hearing them right now. Maybe you believe them right now. Let's talk about it. So first of all, vaccines contain dangerous chemicals. I don't want to inject my precious baby like the one that Caleb is bouncing on his lap right now. We don't want to inject that precious little baby with those dangerous chemicals. Well, let's talk about the first one, thimerosal. It's a mercury-containing preservative, and it's only found in the multi-dose vials of flu vaccine. So we don't see this mercury in any childhood vaccine. We're not injecting mercury into our children. And we've gotten rid of the mercury-containing fillings, too, at the dentist. We don't use those anymore either. So we do know that mercury is something to be avoided. However, mercury is found in the soil. So mercury is found all around in our environment. And the little bit that they do put in as a preservative in the multi-dose flu vaccine is so small. We are exposed to much more mercury in our environments. Formaldehyde. Formaldehyde is a preservative. You've probably heard of that. You think of like a preserved frog in a jar, right, that smells really bad. Well, what people don't realize is the amount of formaldehyde in these vaccines is so small. It's 0.02 milligrams per dose of a vaccine, and the average 2-month-old baby will have around 1.1, so 100 times more than that, in their body as a result of metabolism. We produce formaldehyde as a result of metabolism in a small amount, And it's even smaller, the amount that we put in vaccines. That formaldehyde in the vaccine is way less than what our body naturally produces as a result of metabolism. Another one is aluminum. Aluminum is what we call an adjuvant. It helps heighten the immune response to that vaccine. Aluminum is naturally present in water, foods, and even breast milk. So people are exposed to more aluminum, again, in the environment than in the vaccines. It's in breast milk because of being exposed in the environment and in our foods. So the amount, again, in the vaccines is not anything to be concerned about. Another one is antibiotics. We put antibiotic during the production process. We add antibiotics, this neomycin, to protect against bacterial contamination when we're making it. And then it's removed when it's put into the vial. So neomycin never makes it into the vial to be injected into human beings. It's just part of the production process. And sugars and gelatins help stabilize the vaccine and serve as a preservative, increases the shelf life. This is the #1 trigger for vaccine allergies. So people that are allergic to gelatin are the ones that can have anaphylactic shock from a vaccine. And gelatin is also found in other products, right? Gelatin is found in Jell-O. So there are people that are allergic to Jell-O that will also be allergic to vaccines. And again, people don't know that their child is allergic to Jell-O because if they're an infant, like Caleb, I bet your baby has not had Jell-O yet. No. So if your baby had a vaccine and had an allergy to gelatin, they would have a severe reaction. So does that mean that now Caleb should go on the vaccine registry and say, my baby had a severe reaction because she had her vaccine? Because she's allergic to gelatin? Is it the vaccine that we should be worried about? Or is it the fact that there's a gelatin allergy that a small percentage of people have, that they would have the same reaction at any gelatin exposure? Some people have an allergic reaction to eggs, and the flu vaccine is grown in eggs. So that is another trigger that some people might have when they get the flu vaccine. So we always ask about an allergy to eggs. So let's look at myth #2. Myth #2, we're hearing this a lot with the COVID-19 vaccine. It's better to get the disease and develop natural immunity. We do know that the immune reaction to natural exposure is stronger than through vaccination. And that's because we give people a weakened form of the virus, right? And we may not get that big antibody response because it's a weakened form of the virus. So what people don't realize, though, is keeping COVID-19 alive in the environment increases the risk for mutation. And when viruses mutate, they mutate in a way to promote their survival. So they're going to cause easier, when they mutate, they might mutate in a way to become more transmissible. We've seen that already with the COVID-19 variant that developed in Europe and Africa. It is more easily transmitted. And then the next jump is causing more illness and death. And we saw that with the Spanish flu. The Spanish flu swept through 1 year, caused a lot of illness among the very young and the very old, and then it came back a year later and hit the young and the otherwise healthy. We saw this big spike in the 20 to 40-year-old population that died from their lungs filling with fluid, causing sudden death. So we don't want to repeat that. We don't want to have this mutation ability of this virus because not enough of us are getting vaccinated. So let's look at this video quick. This is a child with whooping cough. Whooping cough is a vaccination offered to new mothers as a booster to protect them from infecting their child, because we cannot vaccinate infants with the whooping cough vaccine. It's not a safe vaccine for infants, but it's good for mothers and anybody that's going to care for the baby. So whooping cough is a very serious respiratory illness, and this is a child who caught whooping cough and was hospitalized. And you can tell me if you think it's better that this child has whooping cough compared to having its caretakers immunized. All right, we'll stop. It's kind of an upsetting video, I think, but you get the point on that. Is that better? If you were the mother of that child, would you agree that that was better for that baby to go through that than for that mother to have a vaccine with very, very low risk and side effects? And there is a YouTube video out there of a mother whose baby actually died from whooping cough, a perfectly healthy, I think, 3-month-old girl that died from whooping cough. And it could have been prevented. She was offered the vaccine and was an anti-vaccine person and didn't get it. And now she is a pro-vaccination person, but she had to suffer those effects. And again, looking at, is it better if you asked every one of these people in the iron lung, if you went each by the head of each of their iron lungs and asked them, are you glad that you got the disease versus the vaccine? What would they say? And it's so easy for us to talk about, other people, but when it's you that's affected, it might change your mind. So 1 in 50,000 children that get chicken pox end up with encephalitis, which leads to hospitalization and can lead to seizures, coma, and death. Chicken pox during pregnancy, so let's say you're a mom who is not going to get your children vaccinated and your daughter grows up and becomes pregnant and is exposed to chicken pox, maybe in her work, we're dealing with children, or her school-age child brings it home, that can result in death to the developing fetus and abnormal development of the eyes, brains, arms, and legs. Measles can result in miscarriage or stillbirth if women get it during pregnancy. And hepatitis B and the mumps virus can cause male infertility. So these are things that are out in the community, chicken pox and hepatitis B, and these are things that we can vaccinate to protect ourselves throughout our adulthood. So myth number 3, are you seeing my screen? Okay, we're good. You're seeing my PowerPoint again? Okay, good. All right, myth number 3 is, my sister's kids never got vaccinated and they've been healthy. Well, I want to shout this from the rooftops right now. Is the reason why they're healthy is because everyone around them is vaccinated. When we stop vaccinating, we're going to go back to what we saw in history, is we're going to see the emergence of these viruses again, just like we've seen with the measles epidemics that we saw at Disney World, where a lot of people were sick. And we saw one in New York among the unvaccinated in a New York neighborhood. We're going to start to see these things come back. And luckily for us, right now, the percentage of people that are anti-vaccinators is low. We're lucky that there's not as many anti-vaxxers as there are people that believe in vaccination. But it is spreading, and it is spreading even more so with the COVID-19 vaccine. We're seeing an unprecedented number of people that are saying they're not going to get the COVID-19 vaccine. And I wonder, do they remember the history of the polio and the smallpox vaccination efforts and what success we had? I'm thinking not, because you would have to be in your 70s right now to remember the 40s and 50s, 70s and 80s. I think a lot of people that I see online on social media that are talking about it are anywhere from 20 to 50 to 60 years old, are the people that I personally know that are anti-vaccinators. So let's look at what this pediatrician says about his experience.
Tonight, I'll be eating loaded tots for March Madness. Thanks, Boo. I think you better double them tots. No, this me was last year.
I've seen this commercial 100 times watching March Madness.
Double the madness this year.
So it's back to school week, and in Wisconsin, nearly 50,000 kids are returning with vaccine exemptions, meaning they can go to school without getting all of their shots. Meanwhile, in 2019, measles cases in the U.S. reached their highest level in 27 years, and now some people are questioning whether anti-vaccine beliefs are to blame. NBC's Dasha Barnes talked to a pediatrician who's actually worked with people skeptical of vaccines. We're seeing outbreaks of diseases that we eradicated. There are people questioning decades and decades of scientific research.
The problem is information overload. You go on the internet and you read people who claim to be experts who have very fringe beliefs that aren't backed up by science. And what's apparent to believe? How do they know how to filter through all this information?
Give me a lay of the lands of this area. How common is some sort of vaccine skepticism or hesitancy?
7.5% of the kids entering kindergarten in the state of Oregon had a vaccine exemption for at least one vaccine. National average is about 2.5%.
What is the responsibility of the medical community?
What we want as pediatricians is to protect the children. So let's ask the question, does the MMR cause autism? Study after study says the answer is no. At some point, we need to move on so we can try and find what does cause autism.
In a world of so much information, what is it that cuts through to people?
I'm telling you stories. When I tell the story of the family that I took care of, whose baby died of whooping cough, it's a real reaction. I'll never forget the family. I'll never forget the room that they were in. And that baby didn't need to die. It was preventable. These diseases that we talk about are not just in a textbook. And so if I can partner with the parents, they can see that my concern is not making a buck. It's not doing something for big pharma. It's doing something for this child, for their child that they care so much about.
What do we do about this?
What we do is we learn to tell a better story. We learn to connect with people. We learn to listen. We get our vaccination rates back up to the point where we stop seeing outbreaks. But when we have 7.5% of our kids in the state who have a vaccine exemption, we start to see outbreaks again. As much as we'd like to allow people to do whatever they want, whenever they want, it's a public health concern. You know, for about the last 10 years, I've been out having this conversation with medical providers. How to talk to families. How to listen in a way that people feel heard. That's not taught in medical school.
Is there a light at the end of the tunnel? Where do you see all this heading?
My hope is that people will learn from their mistakes and they'll see what happens to people who get measles, which is a horrible thing to say. I didn't ever want somebody to have to get measles for people to be scared of measles again. I wanted people to believe us that measles was really, really bad. I don't want to go back to the pre-vaccine days. I have to maintain hope that things will get better.
All right. So that's the biggest thing is educating. And unfortunately, the people that are on the front lines, if you ask nurses at Gunderson, including myself, you know, is the COVID-19 a hoax? We would definitely say no, because we've seen it. Never before has Gunderson had 3 units devoted to one illness. We had 3 separate units, COVID-19 units for COVID positive patients. That has never happened with the flu. People compare COVID-19 to the flu. Never have we had 3 units for patients with influenza. And never did we see the death that we saw with influenza. We had people, because I work on a cardiopulmonary unit, we have people with lung infections, lung influenza that have had, you know, required hospitalization. Never once did I see a death from influenza in the time that I've been working there. But we have had deaths from COVID-19. So can you see my screen, my PowerPoint again? So let's talk about herd immunity. This is the big buzzword, right? All we need is herd immunity. Well, that's true. We do need herd immunity, but the best way to get it is through vaccination. We have herd immunity for all these horrible diseases, right? We achieved herd immunity with smallpox because nobody has it. There's no human host. We don't even need to vaccinate. That's the real way to get good herd immunity, is to eliminate it completely. But we may not get that with the COVID-19, but we can get herd immunity with vaccination. We don't know the percentage that we need. The guess is about 80% or more gives us good herd immunity. So here we go. So we have some people get vaccinated. So the blue people are the vaccinated. The red people are the sick. Do we have enough people to prevent illness when we have this sick person spreading it to everybody who is non-vaccinated? So all these blue people are turning red, right? Because this red person is spreading it to people. She's spreading it to her child. He spread it to him at work. It just spreads around, right? The vaccinated, they're okay, right? They're protected. So if you look over time then, this one red person turned all these blue people red. Now they're all sick. Now we will get herd immunity this way, right? Because once you're sick, you're going to have antibodies to be protected for a while. We don't know how long. But that's good. So this person will be okay once these red people recover. But what are these red people, what if they are not able to recover and they pass away from the virus? What if these red people are nurses that can't come to work and take care of the sick people because they're too sick? And now our healthcare is overwhelmed because we have too many sick healthcare workers and not enough beds in the hospitals. That's where we were for a while in California, in New York, and Florida. They had huge healthcare shortages. I had my name on a list to be a travel nurse, but I ended up having to do more at Gunderson. I picked up an extra commitment with Gunderson to help with the COVID-19 issue. But they were offering $125 an hour for nurses to travel to New York and California. They were that short. And they would pay for your travel and they would pay for your apartment. They just needed someone at the bedside to take care of these patients. So if we all get vaccinated, this one sick person, maybe this is a person that for some reason didn't develop antibodies. Sometimes that happens. Some people get vaccinated and it doesn't trigger an immune response. So we have a small percentage that either can't get vaccinated, like I said from the previous list, or didn't make antibodies. They'll be protected because almost everybody around them is immunized. So we've achieved herd immunity. So the way to achieve herd immunity is by vaccinating people, not by letting them get sick and letting that virus mutate around this large population. And now our vaccines don't work. And now we're back to the drawing board making new vaccines, which is great. We can do it in 2 to 6 weeks with the mRNA vaccine. It's going to take 6 months to get it with a traditional vaccine. So the mRNA vaccine is very fast technology. And because of that, people have criticized it, right? Oh, it came out too fast. That's the technology. If we can whip out a new car because we have some new technology and you can get a brand new car, does that mean it's a bad car? It's a cheap car because it was made quickly? Not necessarily if we develop new technology, right? So the mRNA vaccine is new technology, and you can get 1 million doses of vaccine in 1 2-liter container of bioreactor fluid for the mRNA vaccine. 2 million doses. That's how we're able to crank out all these vaccine right now, is because we're using the Moderna and the Pfizer vaccine. Now, I've been told, but I haven't researched it, I've been told that the Johnson & Johnson vaccine is the traditional vaccine. You only need 1 dose. And it's the traditional vaccine, and it takes a little longer to develop. But again, we have so many people supporting this effort. No other vaccine in the past has had full government funding, has created such a race among scientists and research institutions because they wanted to be the one, right, to develop the COVID-19 vaccine. So they had the funding, they had the motivation, and they had the full support of the government and every health agency to crank out this vaccine. That's why it came out so fast. And that's a good thing. It's not a bad thing. It's not something to be afraid of. Myth number 4, there's too much in those baby vaccines. It's not good for them when they're so young. Well, if you look at this screen and you're not mortified by it, then you know that it's okay that kids can be exposed to things in their environment, right? There are more dangerous things in this puddle that those kids are playing around than there are in our vaccines. And we let our kids play in the dirt all the time. They pick up, heaven forbid you have a 1-year-old and they pick up some gum stuck to the bottom of a chair and put it in their mouth. I mean, we're mortified by that, right? But we're not worried they're going to die. We don't race to the ER, right? Or we don't avoid going public places because we're afraid of germs at the fairs and, walking through the barns at the fairs. We're exposed to lots of things in our environment, and we're making antibodies all the time. Have you ever swept a dirty garage? Have you ever been in a barn when they're baling hay and it's just a cloud of dust in the air and you inhale that? our body is exposed to lots and lots of different things, and we're making antibodies, and our bodies respond to that, and it's okay. So if we look at the odds of anybody having an allergic reaction from the MMR or hepatitis B childhood vaccine for any ingredient, even the gelatin, it's a 1 in 1 million chance that they're going to have a reaction. 1 in 1 million doses of vaccine causes a reaction. And it's not a deadly reaction. It just means some reaction that made it to the website that was reported. So there's a 1 in 10,000 chance a child will be struck by lightning. Do we fear lightning every time we go outside? Because there's a much bigger risk. If you compare 1 million to 1,000, that's a much larger risk. That's 1,000 times more of a risk that they're going to get hit by lightning. But do we look at these numbers when we look on social media and you read the anti-vaccination blogs? They're not using that research. And that's the dangerous thing. The doctors know the research, but the average person doesn't talk to their doctor before they make these decisions. And here's the beauty is the stuff in this puddle, and even the stuff that the different things we put into vaccines back before the 1980s, from 1980 to 2000, the number of things we put into a vaccine, the number of antigens to stimulate the immune system, has decreased by 96%. So there's only 4% of stuff in that vaccine compared to the vaccines before 1980. So we have gotten so good since 1980 at reducing what we need to put in vaccines to get the antibody response that there is very little in those vaccines compared to 1980 and before that, and this mud puddle. Okay, another one. Last time I got my flu shot, I got sick, especially with the COVID-19. Some people got really sick. My daughter got really sick for 2 days. She was just down and out in bed. She had a fever. She had body aches. She felt terrible. I got the vaccine. I had no issues. I felt a little more tired at bedtime. That was it. I went about my day. I had no issues. But does that mean that we shouldn't get the flu shot? Sometimes not enough time has passed after getting the vaccine that person may have been exposed and got the flu virus or got COVID-19. Because people get the vaccine, it's still in the environment. They haven't built up the antibodies yet, and they developed the vaccine. Maybe they already had COVID-19 and they hadn't presented with symptoms yet. Maybe they didn't respond to the vaccine. Some people don't get an antibody response. There's a small percentage that don't develop antibodies, and it's like they were never vaccinated. Maybe the vaccine or the virus mutated. In the case of the flu, the 1 year I got the flu, I was upset because I'm like, I got my flu vaccine. I've never had influenza because I always get my flu vaccine. And the doctor said, yep, the flu vaccine, we missed it this year. It mutated, and what we had in the vaccine did not cover the flu virus that's out in the community. And I was good and sick. It was during nursing clinical. I was really sick. I had 102 fever, and I was really ill. So I would not have preferred to have had the flu versus getting the flu vaccine. And some people over the age of 65, they don't get a good antibody response, and they're at risk for getting the flu. But the good thing is when you get the flu shot, it at least reduces the chance that people will have to be hospitalized. Even with COVID-19, they're saying the same thing. If you get the vaccination, you may still test positive for COVID-19, but it's less likely you're going to need hospitalization. And that's the best we can do, right? All we can do is the best we can do. We're not a perfect society. All we can do is the best effort. So in 1990, we came up with a National Childhood Vaccine Injury Act, which required any doctor who had someone with a reaction to put it in this reporting system. This is an online reporting system. It's called VAERS, Vaccine Adverse Event Reporting System. So any event, even if it's minor, can be entered into this system so we can track. Doctors don't want to be injecting our children with something that's going to cause them harm. So we want to have a reporting system so we can track if there's a problem. We get a bad dose of vaccine and everybody's getting sick from it. We want to know that. We're not just injecting people randomly, right? So we have this nice reporting system. And when we look at the COVID-19 vaccine, there have been many, many vaccines already delivered, and we have only 21 cases of an anaphylaxis. And this was given, this was a couple of months ago when I developed this PowerPoint. Out of 11.1 million doses, 21 cases had a severe reaction. None of them resulted in death. But do the math on that. 26 divided by 11.1 million, and then multiply that times 100, that's your percent. That's such a very, very small number. It's a very safe vaccine, one of the safest vaccines we've developed so far. But again, because of all the social media and the doubt, and that has been created by our political environment. Unfortunately, our political environment is very polarized and we don't listen to each other. So we have extreme sides that don't listen to one another. And that's where we have this lack of trust. And that's the big thing. I think the political divide has caused a lack of trust in our government. When you look back at the first slide where I had the children, showed the children lined up at the desk, and there were people lined up at work. If you look at the polio vaccination effort, they trusted their government in the 1960s a little more, not completely, but a little more than today. Today, we don't trust anybody, and we're putting our health at risk. We're taking a public health issue, which is COVID-19, and we're making it a political issue. It's not political. The virus is a living thing affecting human health. That's a public health issue. Who do we talk to about health issues? Your local politician, the WISM news guy in the morning? Or do you talk to your doctor and say, show me the evidence this vaccine is safe? And if that is a good doctor that you have, they will show you the evidence that that vaccine is safe. Because I've done it with my own doctor. I said, I asked, tell me about this vaccine. It's new. It was the HPV vaccine for my daughters. I said, tell me about this vaccine. I'm hesitant. Tell me about it. And we talked, and I felt better. So back in last May, only 1 in 4 said they will not get the coronavirus vaccine. I have to look at what the latest is. I think I heard 40% lately will not get the vaccine, but we'll have to see. So what do we know? People are saying it's new, it hasn't been properly tested. It has been properly tested. Multiple clinical trials occurred over the summer and fall, and there are over 300,000 participants per trial, and there were no adverse reactions. And another thing is they allowed people to take Tylenol and ibuprofen during those clinical trials. For some reason now, they're telling people they can't take Tylenol and ibuprofen if they get their vaccine because it somehow interferes with the immune response. That's not true. So that's one of those things where you have to do a little research. And I did the research on that because I thought if I'm going to get this vaccine, I'm not going to suffer miserably for no reason if I can take Tylenol and ibuprofen. So I did a little research on that. And I did find that the studies where they proved that it was 90 to 95% effective at antibody response, they allowed their people to take Tylenol and ibuprofen. So if you're going to get the vaccine or you know someone who's going to, it's okay to take Tylenol and ibuprofen. I prefer Tylenol because it has nothing to do with inflammation. It's just a pain reliever and a fever reducer. So if there was any hint of a possibility that it interferes with the inflammatory response, if you take Tylenol, you're not going to be messing with that inflammatory response. So it's very safe. Adverse reactions so far is 0.2%, very, very small percentage. And we've only had 1 death so far out of 5 million vaccines. We've given way more since then. This is a PowerPoint from a month ago, so we've given way more. 1 death, and it was a doctor in his 50s, and it occurred 2 weeks after the vaccine. They still have not determined it was the vaccine, but it was the only thing that was different in his health was he had the vaccine. And so that's still being investigated, but that's the only hint that maybe there was a death related to the vaccine. Current number of deaths due to COVID-19 as of January were, 400,000, almost 400,000, right? That's a lot of deaths that we could prevent with a simple vaccine that are 90 to 95% effective. Huge. Now there's a new one that just came out, right? There's a new vaccine that they're saying is causing blood clots in some people. Again, it's a small percentage. So luckily the Pfizer and the Moderna are the most common vaccines that are available to us right now. So if you're able to get your vaccine, see if you can try to get the Pfizer or the Moderna vaccine because they're really getting good results with that. Other myths that you're hearing out there, it changes your DNA. Well, we already talked about that. It goes into our cell, hooks up to the ribosome, makes the protein, we make antibodies. Nothing to do with DNA, zero. DNA is nicely housed in the nucleus of our cells, surrounded by the nuclear membrane. We're not messing with that. It has a microchip for government tracking. There is no microchip in there. To deliver a microchip requires a needle size of 12 to 15 gauge. It's a thicker needle. I have not seen any video of anybody getting vaccinated, including myself, with anything larger than a 21 gauge needle. So not true. And when people say, oh, that was an artificial vaccination when President Biden was injected with that, needle, there was no needle there. No, it was a retractable needle that the minute the needle goes in the arm, it retracts and pulls into, it's a safety needle, we call it. It pops into the vial, or the barrel, I should say, the barrel. So he delivered the vaccine. It'll have long-term side effects we don't know about. Again, do you worry about that when you go into a dusty barn? I might have long-term side effects from the antibodies I produce to the stuff in the barn right now. No, we're producing antibodies to a foreign particle that our immune system is mounted to do and does it very readily and very easily and does it every day of our lives. When we eat food that's not sterile, and I don't know any food that is sterile, unless it's sterile formula, we're gonna make antibodies, and that's okay. There's no long-term side effects that we should be worried about. There's nothing new in that vaccine other than the mRNA stimulating antibody response that we should be concerned about. The government can't tell me what to do. That's true. The government shouldn't be able to tell us what to do, but we should be trusting enough of health information, not government information, health information, to make a decision about vaccines. And I can tell you the government has been inconsistent. The Trump presidency was hinting at us that the COVID-19 was a hoax and that we didn't need to get vaccinated. Now Trump, out of office, is saying that we should get vaccinated. And prior to, in the Biden administration was saying that the vaccine isn't going to work and the vaccine is going to take years to come out. Well, now the Biden is saying the vaccine is awesome and it's here and it's ready and let's do it. So government, yes, we have to be careful, right? But this is not a government issue. This is a public health issue, and the people we should talk to is not our politicians, but it's our doctors. And that's the biggest take-home point, is talk to your doctor. They're the experts. They know the language of the research studies, and they can explain to you what's going on. Our politicians are not health experts. They rely on health experts, but they're not health experts. The vaccine, somebody said it causes infertility somewhere, that got out there. There's no way that causes infertility. It creates an antibody response against a spike protein. That has nothing to do with sperm and egg meeting each other in the fallopian tube. So there is nothing about that. And COVID-19 is a political hoax. Again, when we look at this virus and the impact it made on the health systems this summer and fall, that is not political. That was not a staged arena for us to look at. It happened internationally. So we're talking about countries everywhere that dealt with COVID-19. It wasn't just a United States Republican-Democrat debate. This is an international public health threat. And the last piece I want to show you is a hospital here in the U.S. in the thick of it, in the thick of this pandemic when everybody was ill. This is not political. These are real. This is a real video of real people. These are body bags in New York. They could not keep up with storing the deaths, the bags of the people that died from COVID-19 in New York last summer. And this is an international picture here. And no, this is an international one, and I think this one might be here in the U.S., but this is a hospital here in the U.S. So let's watch this video quickly.
It's time for a new horizon, a future to look forward to, where your education is essential, no matter the circumstances. It's time to hit that reset.
Well, how do you like that? A Western ad. How appropriate.
Personify your passion with degrees earned safely on campus.
You guys already know this, right? Because here you are in class, making a difference.
And academically challenging. It's time to look to the future. Apply today at westerntc.edu.
We just have to finish watching that. Okay, here we go.
Catherine, Haley, Chris, Rebecca, Kathleen.
I can't exactly remember the exact moment I heard COVID-19. I was supposed to take a trip with my son to Japan, more news, It's like, we'll be fine. And then it just seemed to explode. Initially, we thought we just might need 8 beds. And then as we started getting into the COVID ICU, it became apparent that we were going to have to stretch. These patients have to come in here and they're super sick. So you have to put yourself in their shoes to feel what they feel. You're in a hospital with strangers all around you, telling you to breathe, telling you to cough, and you're restrained, tied down.
Hey Joe, this is Breezy in COVID ICU land. We're getting ready to supernate a patient and cannulate them for ECMO.
I think day 2 of me working my first week in the COVID ICU, I just knew that this was going to get a lot bigger and it could get really scary here. So I called my friend that night and my son was on a plane by 10 a.m. the next morning. He's in Hawaii right now and he's been there since March 11th.
Yeah.
I usually work 7 nights in a row. The day before I have to take a long nap to make sure I can mentally switch and function appropriately, and then you can get through your 12-hour shift. You're trying your best, all the little tricks that you've known that have worked on patients that have had really sick lungs in the past, but these tricks are not working. People are getting sicker. Whenever you put a breathing tube into somebody for the first time, you risk having droplets come out. There's definitely a risk. You do it. Always tell them what I'm doing, even if they are sedated. I always believe that people can hear you and you need to talk to them.
We're turning to the other side now.
I'm going to give you this med. It's for this. You just verbalize it out loud. You hold people's hands. You sit there with them, talk about something that has nothing to do with the COVID-19. You just ask them about them. So I get to know them, their families, because they can't talk to their family. You're that bridge. And all you want to do is make sure that this person can go home. If you're already...
What they're doing here is called ECMO, and we use it during bypass, is we're actually removing their blood, passing it through an artificial membrane, providing oxygen and pulling out the carbon dioxide. So we're basically doing the work of the lungs for them. So you can see the tube where the blood came through, and then we're watching the oxygen levels go up as they were oxygenating it outside the body and then returning it to the body. It's called ECMO.
The max level of support that you can give and their oxygen levels are dropping, there's really not much you can do except just let the family know. And can you imagine holding up an iPad to somebody who's intubated, really sick, and hearing their family tell them goodbye? It's absolutely heartbreaking.
I'm going to bring the camera over, Tim, okay?
Tears are coming down your face. I mean, you're human. This sucks. We had a coworker, very young. We don't know if she got actually exposed at work, but she started feeling sick and she took herself off the schedule, doing it at home, like a lot of people do who test positive. But it just came to the point where she couldn't do that.
Hey, sweetie, you're in the hospital, okay? You're at Harborview. We're going to take good care of you.
She was with us for 7 days on that breathing machine. She would write on a board. Being a nurse, she would always want to know what her vent settings were. I think we were all standing outside the room when we knew that we were going to take that breathing tube out. And we were all so scared. We all held our breath. She had that tube out and she was fine. We finally won one. We did not let COVID win. We won. Until we get a vaccine, there is no way that this can't be part of our everyday life. We're going to adapt to it. We're going to learn from it. And we're going to grow from it.
If you notice what she said in there is not until we get a vaccine. So here we are, we have a vaccine. Now the question is, are we going to use that vaccine to get out of where we've been? And again, never before, yet Gunderson have we had 3 units devoted to COVID. So it's a very serious illness. And I have seen young people with no health effects get very sick from this disease. And again, if it's preventable from a vaccine, and it was you that was one of the small percentage that got sick, wouldn't you wish that everybody did their part to protect you? And that comes to our last slide, and that is, I think it's so important that we learn from the past. If we look at these pictures here, these are all examples of our past where we have used the polio vaccine to overcome a huge, devastating disease. So hopefully you guys can spread the information in an educated way so the uneducated can say, oh, yeah, that makes sense. I guess I never really thought of that. So be a source of knowledge for them, and I'll take any questions that you have now.